Hello, in this video we will be looking at the specific heat capacity of a body. So let's say we have three objects, one made of, let's say, copper, one made of aluminium, and a container of water. Okay, so each of those are all different sizes, and that represents in some ways their density, copper being the most dense and water the least dense. Now, they're all a kilogram in mass, and let's say we applied some energy to it in the form of heat energy, and our aim was to raise the temperature by 1 degree C. So which of those would take the most energy to raise the temperature by 1 degree C? Well, in fact, the answer is water would take the most energy and copper would take the least energy. In fact, the energy to raise 1 kilogram of water by 1 degree C is 4,200 joules. To raise a kilogram of copper by 1 degree C is 880 joules, and to raise a kilogram of aluminium by 1 kilogram is 880 joules, and the energy required to raise a kilogram of copper by 1 degree C, or 1 Kelvin, it's exactly the same thing as temperature difference, is in fact 380 joules. So you'll see that by far it takes most energy to heat up a kilogram of water. Okay, and this is all to do with specific heat capacity. In fact, the specific heat capacity of water is 4,200 joules per kilogram degree C. For aluminium, the specific heat capacity is 880 joules per kilogram degree C, and for copper it's 380. So I'll rub these out and I will give you an equation. Now, okay, in physics, for thermal energy is often represented by the letter Q. So let's have an equation. Q is equal to M, which is mass, times C, which is specific heat capacity, times change in temperature. Now, for some subjects, in some syllabuses, you see the equation written as Q equals mc times change in temperatures of theta. They are equivalent. The delta theta there is the same as the delta T there. So it's just a change in temperature. M is the mass, and for SI units, the mass is in kilograms. However, sometimes we can use it as in grams. And the C there is the specific heat capacity, and the specific heat capacity C has got the units of joules per kilogram degree C. Now, if you're working in grams, which you can do, this can be written, and often in chemistry it's in grams, it's joules per gram degree C. In fact, so for water, the specific heat capacity of water, which is CW, specific heat capacity of water, is equal to 4,200 joules per kilogram degree C, and the specific capacity of water is equal to, in grams, it's 1,000 times less, it's 4.2. So it takes 4.2 joules of energy to increase the temperature of 1 gram of water by 1 degree C. And in fact, often that equation, if you ever wanted to find out what specific heat capacity is, that equation can be rearranged in terms of specific heat capacity. So therefore C is equal to Q, which is the energy transferred. So it's very useful to think of that as, so I'll write energy transferred. Okay, that's Q. So C equals Q divided by mass times change in temperature. So if you look at the units, that would be Q, that's energy, that's joules, divided by mass. I'm going to write this to the -1 per, yeah, I'll write this in an indice way. That's kilograms to the -1, and that could be written change in temperature. We can call that Kelvin to the -1. So another way of writing it could be like that. Okay.